My name is Lewis. I've been leading Farming Smarter's precision ag projects for this past growing season. So I'm just going to give you a bit of an overview of one of our projects, our soil sensor project. So what we've done is we've taken about a dozen fields all across Alberta, from as far north as Falher and Peace Country, a couple fields in Bow Island, Drumheller, Lethbridge area. And in each of these fields, we've kind of teamed up with the producer, and we've run a number of soil sensors over each of these fields. And we've really focused on electrical conductivity. So EC kind of tends to relate pretty strongly to soil moisture, soil texture. And in addition to that, we've kind of gone in after, we've taken soil nutrient grid samples, aerial imagery, so kind of as much data as we could. So that was kind of step one of the process. So we gathered all this data for all these fields, kind of put it on the shelf for a minute. And the next step was to kind of put variable rate technology into action. So for each field, we did a variable N trial. And what's kind of useful about doing that is one, that's one of the factors that's most commonly varied with the technology. And two, there's a response that nitrogen's going to generate that we can observe, we can detect it, and we can predict it. We know that as we increase N, we're going to have boosted yields. So we kind of know there's an expected return on that nitrogen application. But of course, that's going to happen more under controlled conditions, plot research kind of thing. But once we take into account some of the variability in the field, this is an elevation map for this same site in Drumheller. And you can see there's quite a bit of variability in elevation, quite a bit of variability as well in EC. So these things are going to kind of serve to obfuscate the results of our little experiment there. So this next slide, this is what our treatments look like. You can see the different rates of nitrogen replicated and randomized within each of the blocks. And each field we kind of tried a different design as well, just to see what was going to be the most effective. Where are we going to generate the best response curve? So this next slide, this is what our yield actually looked like. So it's an interpolated yield map. So it kind of takes all those data points, kind of blurs them together, just to kind of make it a little bit more manageable. And I mean, compared to how succinct our prescription looks, it's kind of a dog's breakfast. It's a bit of a mess. And even if I throw up our plots or our treatment blocks on there, it's pretty tough to really pull anything out of there. But I'm going to zoom in on one of our blocks here a second. And you can see in the center there, the two. You can see the two center 120 pounds of actual N. I mean, there's definitely a response there. And on the right-hand side, there's a couple zero strips, and you can see that they yielded less than the other ones. So we definitely have seen the response from our variable N. And this is where things start to get interesting. So at this point, what we're going to do is we're going to reach back into our shelf of all the data we collected, and we're going to overlay each layer of that data on top of this. So we're going to take our EC, we're going to layer it on top of this, and then we're going to look and see, does that EC, does that account for some of the variability within each of these treatments? Is that going to tell us why we did or did not get the response we expected from the nitrogen? Next step, soil nutrients, pH, all these layers, we're going to put them all on top. And at the end of the day, we're going to come up with a pretty good idea why and where the variable rate technology does work and why and where it doesn't work. And that's going to give us the information we need to come up with probably a more optimal, more scientific rooted process to coming up with variable N prescriptions. This slide's just kind of a quick hit. It shows that there was a distinct yield response for our varying rates of nitrogen. So at the end of the day, when we're working with precision agriculture and variable rate technology, we're really starting to wade into the ocean of big data. For just a yield map in itself for a quarter section, I mean, you're looking at 50,000 unique and discrete pieces of information. By the time you add in, another 10 layers of information, you're looking at somewhere in the neighborhood, 500,000 different pieces of information. So one of the big challenges moving forward is to decide exactly how we're going to summarize that information. Are we going to break it down into 3 zones, 5 zones, 9 zones? What's the most effective way to bring that data, turn it into knowledge, and use it on our field? And the other part of that is going to be what piece of information are the most important. So how many zones, what information is important. At the end of the day, we're going to be able to sort of streamline this, make it a little bit more optimal. So we can boost the yields, boost the returns on the investment. So with that, this is our last slide.